Chapter 5, Question 18. Simplify each expression. Before we begin with parts A through C, let's first define that an integral from A to B is looking for the area. This type of integral, because it is defined with variables, as we see here, is called a definite integral. When we have an integral that is left open, like this, with no variables, this is an indefinite integral, and this is looking for the antiderivative of the expression. Let's say, for example, big f of x. Part A asks us to evaluate this indefinite integral. Because it is an indefinite integral, we know that we're looking for big f of x, or in this case, the d of m. In order to start to evaluate the indefinite integral, we must first expand this original equation. We will do this by making this integral equal to m to the sixth minus 2m cubed plus 1 all over m to the fifth dm. Then, to continue to make this easier, when we need to evaluate the indefinite integral, we will put the m to the fifth under each variable. So it will be m to the sixth divided by m to the fifth minus 2m cubed over m to the fifth plus 1 over m to the fifth dm. Now we are able to simplify some of the variables. So the integral is now equal to m, because we can cross out a 5m down here and 5 of the 6 m's, leaving just 1 m there. Then, in the next part, we are able to bring minus 5m from here and make this 3 minus 5, which leaves us with negative 2m to the negative second power plus m to the negative fifth dm. We are able to do that last to the negative 5 because when we have an exponent on the bottom, it becomes a negative. Now we can remove the integral sign because we have moved back. Now we are going to find the antiderivative. So, to find the antiderivative, you do the variable and then the exponent, which in this case is a 1 plus 1 over this variable here, which is 1 plus 1. Then we do that again with the 2, and we get negative 2m to the negative 2 plus 1 over negative 2 plus 1 plus m to the negative 5 plus 1 over negative 5 plus 1, and always add a plus c. This plus c is very important here because it means that you're always adding a constant, which means that the antiderivative is correct in all areas. Then we can take this equation that we have made and break it down into m squared over 2 minus 2m to the negative 1 over negative 1 plus m to the negative 4th over negative 4 plus c. And once again, break this down again and get m squared over 2. Now we have a negative and a negative, which makes a positive. So we get positive 2m to the negative 1 plus 1, and there should be, and because this is negative 4, excuse me. Then get plus m to the negative 4th over 4 plus c. This is our final answer. Part B is asking us to find a definite integral, so an integral with boundaries, as we see here. Part B is asking for the integral from 0 to 5 of the derivative of the square root of x squared plus 11. To make this more clear while we're writing, we're going to say that f of x is equal to the square root of x squared plus 11. Then put that in the cloud because this is not part of our original equation. Now we can rewrite our equation using our f of x and see that the integral of 5 to 0 of the derivative of f of x d of x. This is equal to the integral from 0 to 5 of f prime of x d of x. Writing d of x here is extremely important because it shows that it is an integral, and it shows with where you're evaluating that on what axis. It also gets you points for the AP test. Now to evaluate this integral without using a calculator, we're going to find the indefinite integral, which brings that the indefinite integral of f prime of x is just f of x. So the indefinite integral is f of x with the boundaries from our original definite integral of 5 to 0. Then we'll put in f of 5, and so now this is equal to f of 5 minus f of 0, which is equal to, using our cloud, we know that f of x can go in here. So this means that we have f of 5 is equal to the square root of 5 squared plus 11 minus the square root of 0 squared plus 11. This is equal to the square root of 36 minus the square root of 11. Break it down one last time, and we get 6 minus the square root of 11. Now don't forget to write your units, because as I explained in the first slide, that when we have a definite integral, we are looking for area. So we get 6 minus 11 square root of 11 units squared. Again, make sure you use your unit. Part C is asking us to find the derivative of the integral from 0 to 5 of the derivative of x squared of the square root of x squared plus 11 dx. Knowing what we know from part B, we know that the integral from 0 to 5 of the derivative of the square root of x squared plus 11 is equal to 6 minus the square root of 11. So now what all we have to do is find the derivative ddx of 6 minus the square root of 11. This is equal to 6 times to the 0 minus 1, bringing down this previous 0, so we have 0 times 6 to the 0 minus 1, minus bringing down the exponent, which is 0 times square root of 11 to the 0 minus 1. Now, because we have times both terms by 0 here and here, we now know that the derivative of the integral of 0 to 5 of the derivative of the square root of x squared plus 11 is equal to 0, which is our answer for part C.